facility, which produces essential products for the railroad industry, the mining industry, the power industry, the automotive industry, the communications industry, the steel industry, and even the recreation industry. The key to this steady growth can be found in two words: specialization and service. Specialization because even though copper was one of the first metals discovered and used by man, it has many elusive properties, and there are no easy handbook answers to many of the production problems that crop up. So the Electric Materials Company maintains its own research department, which not only performs day-to-day quality control checks on hardness, conductivity, and tensile strength, but also does long-range research on grain structure and the effectiveness of insulating materials. Specialization does not end at the laboratory door. It extends right onto the production floor. To control quality, you must control as many of the intermediate steps as possible. So at TEMCO, nothing is farmed out. Every manufacturing process essential to the success of its products is kept under one roof, be it hot rolling, cold rolling, drawing, forging, casting, machining, or fabricating. Service, the other factor in the pattern of growth, is harder to pin down. It's an intangible, perhaps best symbolized by such things as scheduling to the day and maintaining that schedule, even if it means a shipping clerk has to stay over for 5 minutes to make sure a rush order goes out. It means a machinist who would never let an off-tolerance part get past his watchful eye because his father held the job before him and the family has a reputation in town to protect. Or the executive who makes a ritual out of answering every piece of mail the same day it's received. Small items, even silly ones perhaps. But in an age when business transactions have become largely impersonal, it's reassuring to know that your order is being watched over by men, not machines. Let's see how this combination of specialization and service go to work for you when you order mill products from TEMCO. Everything starts here with the standard 250-pound copper wire bar. But at TEMCO, only scalped wire bars are used. Notice that shiny surface? The reason for this is that when the wire bars are being poured, any little impurities or bubbles come to the surface. These can impair the surface finish and even the strength of the finished product. So TEMCO orders all of its wire bars with this top layer of impurities scalped off. It costs a little more, but your products end up being better. After being heated to the proper temperature, the wire bars receive a preliminary hot rolling. Depending upon their final use, they may then be cold rolled, annealed and pickled, drawn, annealed and pickled again, and drawn again. Because there is such a wide variety of applications for mill stock, the Electric Materials Company decided that some customers were paying for more processing and higher quality than they actually needed. So it shattered industry tradition and pioneered a program of multiple grades of quality copper. Now buyers have the freedom to choose the specific grade they need. And because the Electric Materials Company is a small, flexible mill, they can get that quality level in even small quantity orders on an almost overnight basis. Specialized shapes are no problem either, because TEMCO maintains its own tool and die shop to further shorten the time between order placement and delivery. If tight tolerances have you worried, you can be confident that your specifications will be equaled or bettered when you place your order with us, We have the equipment and a half-century's experience necessary for precision copper production. As copper specialists, TEMCO maintains its own research and development staff, studying such basic areas as the relationship of surface finish to contact resistance. This, coupled with a fully staffed engineering department and finishing division, means that you can obtain a complete package from TEMCO on complex bus bar installations. There's no need to deal with several suppliers. Just send us your specs and we'll take it from there, including design and engineering, rolling, cutting, drilling, bending, and numbering each piece to match the print. When the shipment arrives on the job site, it can be simply bolted together without any on-location cutting and forming and no waste. Even in the little things, the Electric Materials Company strives to save you time and money. You don't need a slide rule to figure out our price sheet. And our new method of strapped packaging of bar stock saves you shipping costs and handling time over conventional containers. And speaking of shipping, Northeast Pennsylvania is within a 500-mile radius of 80% of this nation's population, midway between New York and Chicago. For these reasons, and many others, the Electric Materials Company has continued to serve an ever-increasing number of customers with its copper products. Recent additions which spell greater service for you include 53,000 square feet of new manufacturing and warehousing space, enabling us to make immediate shipments of bus bar from a tremendous variety in stock. In-house electroplating capability, and an atmospherically controlled furnace for bright annealing. Yes, it started with the trolley. And in the 50 years since the Electric Materials Company first started supplying copper products for the interurban railway system, we've seen a lot of changes in design and in copper specifications. But some things remain constant. The knowledge born of specialization, the honesty of fine craftsmanship, and the sincere desire to serve. These values are unchanging. These are the hidden extras you get when you specify mill products from TEMCO, the Electric Materials Company.
During the early 1900s, a new method of transportation broke upon the American rural scene, the electrified interurban railroad. This was the country counterpart of the city's trolley cars. It was, in effect, America's first commuter system, used to link many small rural towns to the big cities. The biggest boom in interurban railroading occurred in the Midwest states of Illinois, Indiana, and Ohio. These systems required vast amounts of electrical supplies, traction motors, commutators, trolley wheels, wire, and power distribution equipment. To supply these needs, many small electrical companies came into existence. Among them, the Electric Materials Company, founded in 1915 at Northeast Pennsylvania. Business was good until the late 20s, when the combination of the private car, the gasoline-powered bus, and the disastrous stock market crash drove the interurban lines out of existence. While many of the electrical supply companies followed their main customers into oblivion, the Electric Materials Company not only survived, but grew into this modern integrated copper manufacturing facility, which produces essential products for the railroad industry, the mining industry, the power industry, the automotive industry, the communications industry, and even the recreation industry. The key to this steady growth can be found in two words: specialization and service. Specialization, because even though copper was one of the first metals discovered and used by man, it has many elusive properties, and there are no easy handbook answers to many of the production problems that crop up. So the Electric Materials Company maintains its own research department, which not only performs day-to-day quality control checks on hardness, conductivity, and tensile strength, but also does long-range research on grain structure and the effectiveness of insulating materials. Specialization does not end at the laboratory door. It extends right onto the production floor. To control quality, you must control as many of the intermediate steps as possible. So at TEMCO, nothing is farmed out. Every manufacturing process essential to the success of its products is kept under one roof, be it hot rolling, cold rolling, drawing, forging, casting, fabricating, boring, or final assembly. Service, the other factor in the pattern of growth, is harder to pin down. It's an intangible, perhaps best symbolized by such things as a shipping clerk who stays overtime to make sure a rush order goes out on the promised day. A machinist who would no more let an off-tolerance part get past his watchful eye than he'd miss the grape festival in September, because his father held the same job before him, and his father before him, and the son has a reputation in town to protect. Or the executive who makes a ritual out of answering every piece of mail the same day it's received, be it an inquiry, an order, or a complaint. Small items, even silly ones perhaps, but in an industry and an age dominated by giant impersonal corporations, it's reassuring to know that your order is being watched over by men, not mechanical monsters. Let's see how this combination of specialization and service go to work for you by following a typical order through the mill from start to finish. Here in the Cleveland, Ohio maintenance shops of the New York Central Railroad, this large traction commutator has just been pulled. It's too far gone for any more turning down, so it will be replaced from the Central's shelf stock. What's left of this one is returned to Northeast to start its life cycle over again. The first step is a complete engineering review. With over 20,000 commutator prints on file, the job of pinning down exact dimensions and metallurgical specifications can be accomplished quickly, even though the old commutator may be damaged almost beyond recognition. But engineering means more than just copycatting old ideas. Original development is constantly going on, and TEMCO refilled commutators often incorporate changes which take into account improvements in the strength of the copper, insulating properties of the mica, and the latest mechanical design. Refilling, by the way, is a cost-saving concept long associated with the Electric Materials Company. With the specifications pinned down, the production department can usually start work immediately because an inventory stock is kept on hand at all times, permitting access to up to 15,000 sizes. However, if the size is something really out of the ordinary, or if inventory levels are low, it can be quickly rolled to order in TEMCO's own rolling mill. The pure electrolytic silver-bearing wire bars are first heated in a carefully controlled oven, which keeps scaling to a minimum. Then through the mill for progressive sizing and application of the bevel necessary for the commutator segment's wedge shape. It's a pretty sight to watch the red-hot copper snaking through the rolls, and one you'll not see too often. For only TEMCO, of all independent commutator builders, has the volume to justify the operation of its own mill, in spite of the extra step of quality control which it affords. A cold rolling follows, which gives the copper a preliminary sizing necessary for the bench drawing which is to follow. Probably the most crucial step in the entire preparation of commutator copper is bench drawing. Not only does this operation determine the final dimensions and the surface finish, but also the cold working of the metal greatly alters its hardness, grain size, and tensile strength. As a result, up to 4 final draws with intermediate annealing may be necessary to obtain the exact properties called for in the specifications. The use of universal dies permits an infinite size range, and to date, TEMCO has drawn over 10,000 sizes in commutator wedge stock alone. And failure or wear of these dies won't halt production or slow up delivery schedules, because TEMCO maintains its own tool and die shop. It's another service extra, as is plating of the dies to give an ultra-fine finish to the copper, something that's hard to measure, except in terms of pride of workmanship. While quality has been spot-checked at every operation, the copper gets a real fine tooth going over at this point. A sine bar is used to determine the angle of the wedge, the flatness and concavity, all essential to a tight commutator. The surfaces must be flat to within 0.02 of an inch per inch, and samples are cut off and sent to the laboratory to see if hardness and tensile strength are within tolerances. In this age of rockets and missiles, white gloves are a common sight in plants building components for America's space race. But you don't ordinarily expect to see them in a big copper mill. However, the Electric Materials Company is extraordinarily fussy about its finish. So after the drawing compound has been washed off, all handling operations are performed with cotton gloves to keep the oils and acids of body perspiration from pitting the surface. It's one of those things that some might call unnecessary, but we consider essential. From here, some are punched and require no further machining. Others are sawed to rough shape and will be finish machined later. At the same time, in another department, the mica is being blanked to match the segments. After years of laboratory and field testing, TEMCO has standardized on alkyd vinyl bonded mica segment plates. Alkyd vinyl will stand temperatures up to 400 degrees Fahrenheit, in contrast to shellac, which flows at 275 degrees. And that difference gives you an extra margin of dependability in extreme applications. This preformed mica and binder have been built up in layers, usually a minimum of 3, and sometimes as many as 7, with individual heats between each layer to assure complete binding. Joints in the mica are staggered to maintain uniform strength throughout the piece. The operator must move swiftly and surely because the binder sets almost instantly when it hits the cold forming mold, which is pre-coated with mold release compound. Maximum insulating properties will be developed later as mica is compressed to proper thickness and also stabilized through baking and pressing. The stacking department is the grand central of commutator building, where all the components come together for final assembly. Here is where craftsmanship and painstaking attention to detail pay off. The copper and mica are carefully counted and recounted because radial accuracy is a factor not only of wedge angle, but the exact number of segments and the location of the first segment by the setup man. Stacking takes place in dummy rings, a building ring on the bottom and press ring on the top. Exact 90-degree assembly is a must, for any skewing of the segments will cause poor commutation. To assure this, TEMCO has a wide variety of hydraulic presses, ranging up to 300 tons capacity, which are constantly checked for pressing accuracy and parallelism. After an initial press, some commutators are given a short oven treatment to develop dimensional stability. Others bypass this first bake and go directly to the boring lathe, where the brush end is faced off and the V-bore is machined. This step must be precise, regardless of whether the commutator is to be of the V-bound type or of the arch-bound type. With the V-bound commutator, most of the pressure from the cap and shell is carried on the 30-degree surface, but the amount carried on the 3-degree surface is very critical. Either too much or too little pressure at this point will cause roughness in the overhang area. The arch-bound commutator is inherently smoother than the V-bound because there is no pressure at all on the 3-degree surface. However, precise machining is still essential because clearance must be maintained between the inside diameter of the segments and the shell, and between the 3-degree surface of the segments and the mica cone. To preserve this clearance and prevent possible future shorts, a solastic compound is added on the 3-degree surface during assembly to seal out moisture and dirt. Quality machining of the steel parts complements the work done on the copper. If your order is for a refill, the shell is given a complete checkout. When needed, the shell is turned to specifications. With extremely old units, further upgrading may take place with customer approval to take into account modern design improvements. And of course, orders for complete units get new forgings or castings depending on design requirements. You may, if you wish, order assembled segments, machined and banded. These will be delivered completely bound with wire to maintain alignment. Copper, mica, and steel are mated, and a finished commutator begins to take shape. Tight, true, and smooth because of rigid fabrication tolerances. Mica rings insulate conductor parts. The persistent checking continues. The critical 3-degree surface is sealed with solastic compound. Another mica ring and more solastic on the front end. The end ring is placed and heavy bolts added. These are tightened only enough to pull the end ring to a snug fit at this time. Later, under tons of pressure in a press, they will be taken up tight to hold the copper and mica in a grip that will keep the commutator smooth under grueling traction conditions. With all parts now in place, the assembled commutator returns to the oven, where the solastic seals are heat set and the mica is further cured. Still hot from the bake, the assembled unit is placed in one of TEMCO's parallel presses, where under precisely calculated pressure, the end rings grip the 30-degree surface of the copper. The ring bolts are tightened and assume the pressure. No further tightening by the customer is necessary. No longer needed to hold the copper and mica segments in alignment, the building rings are removed to leave the commutator sustained now, for the first time, by its own internal pressures. Gauge accuracy must be maintained. No segment is allowed to shift during baking and pressing. With the retaining pressures now on the end rings, the unit returns to the oven, where further heat application will cure the mica parts in their final position. This cycle of baking and pressing may be repeated several times until TEMCO is certain that the commutator is dimensionally stable. Seasoning to obtain stability is now complete, so the brush diameter can be turned. Traction motor commutators receive an additional processing step, known as spin seasoning, to assure smooth operation. In spite of a thorough pressing and baking cycle, the tremendous centrifugal forces and temperature extremes encountered in unusual service may cause the segments to readjust themselves, resulting in a rough commutator. This series of high-speed spinning cycles under heat is one of those additional precautions taken to assure no in-service trouble after the commutators are installed on the armature shaft. A final surface finishing step takes place while the commutator is still mounted on the spin table. With spin seasoning completed, the final step is the application of an insulating and heat-resisting varnish to all non-working parts. This gives added protection during long periods of shelf storage and use. At the final inspection station, all mechanical dimensions are checked against the prints once again, and the commutator subjected to proper bar-to-bar and bar-to-ground short test with both AC and DC test equipment. Years of commutator building experience have led TEMCO's engineers to develop new methods and machines, such as this automatic slotter for smaller mine and mill commutators, or this customer extra on the pre-slotted surfaces of a traction commutator. Note that the bright surfaces are not the conventional tin dip, but silver electroplating done in our own plant. Like the surface finish of our copper, accurate slot control is one of those little things in which the Electric Materials Company takes particular pride. Yes, it started with the trolley, and in the half-century since the Electric Materials Company first began building commutators for the interurban railway systems, we've seen a lot of changes in commutator design and in material specifications. But some things remain constant. The knowledge born of specialization, the honesty of fine craftsmanship, and the sincere desire to serve. These values are unchanging. These are the hidden extras you get when you specify TEMCO, the Electric Materials Company.